If you're a C++ or a C developer, guys, unions, right? How much do you guys love unions out there? And wish you could use unions in C#. Let's talk about unions, guys. I want to talk about them. Unions, right? Unions. And if you don't know what a union is, go Google it. I'm not gonna describe a union, but I'm gonna show you how you can implement a union in C# or in .NET very, very easily. This has some restrictions, and once I implement it, I will show you guys. If you don't know, if you already don't know, we can create a struct. We'll call it a byte array, right? And this struct is gonna have a public byte, byte 1. Let's create 4 bytes. 2, 3, and 4. Very simple, right? 4 byte, here's an array. That's awesome. And what is also 4 bytes, guys? What is also 4 bytes in C#? Well, an int is 4 bytes, right? So wouldn't it be great if we can map these bytes to this integer without having to do any special magic software, any special code? Let me go back to full screen here for you guys. Sorry. You think they're nonsense, Massey? Okay. Best byte array 2015 coming online, guys. So here's a quick byte array which just maps 4 bytes, right? But also 4 bytes is an integer. Wouldn't it be great if, for whatever reason, I don't know what your reasons would be, I'm just giving you guys the power. You decide how you want to use it. Wouldn't it be great, though, if we can map these bytes onto the same memory address of this integer, right? That's basically a union. Well, we actually can do that in C#. We can actually do that. We want to put an attribute on here. If you don't know what attributes are, please go look up attributes, guys. Attributes are kind of amazing. You should implement your own attributes for all kinds of stuff. I don't see enough attribute usage used in C#, but I would like that. What we're telling this is, here's a struct. I want to tell the compiler and the runtime, I want to explicitly lay out the structure of my struct. And it will say, okay, go for it. So that's on a struct. You can put a struct layout. We can then use field offsets for every field within our struct, right? Now, field offset is the byte offset. The byte offset from the start of the struct array, right? So, well, since these are bytes, we just want byte offset of 0, 1, 2, 3, and 4. And how we bind this into a union is we can also set the int to have a field offset of something that's already been used, right? These are not have to be unique. I can have byte 1 and byte 2 share the same offset so that anytime I modify byte 1, byte 2 would also get modified for whatever reason. I don't know why you'd want to do that. But here we go, right? We have 4 bytes, which is the size of an integer. We explicitly laying out the offsets. And then we can say this integer should also map into the first address space, the first offset of the struct. And these will lay out on top of each other. And that's how we can do unions in C#. So let's go test this real quick, right? So I have a byte array. BA. I want to say BA dot byte 1 is equal to 0. Let's use the hex codes here, right? It'll be easier to see in memory, or however we want to spit this out. You know what? Let's not. I'll make this easier for you guys. We'll say 128 0. We use half a byte, right? 0, 0, 0, right? We're not setting our integer. We're not setting our integer. Let's then just console write line. This is a very simple one, guys. We'll move on to something else here in a second. Byte 1, 2, 3, and 4. Byte 1, 2, oops, 0, 1, 3, and 4, and then also we'll get int 1 in here, right? I1 is equal to 4 here, okay? And then we can say a ba.byte. I see my bug. I already see my bug. I'll go fix it in a second. Let me just lay this out. We just want to see what data is going to be in here, right? And ba.in. Change this to 1, 3, and 4. Alright, so if we run this, if we fix this, what doesn't it like? You sub on if okay. Oh, that's fine. Because it's a struct. So we'll initialize it to 0, and we'll see if this gets overridden, right? Let's put a breakpoint here, and let's just see what kind of data we're getting. So, our integer now is 128, right? So if we set byte 128, 000, our integer is getting changed. More to the point, if we initialize everything to 0, and more likely how you'd use this is manipulating our integer here, right? If we manipulate our integer, and let's do this as a hex, right? So we can see what's going on, 00, 00, 00, FF. Let's set the first byte to what we want, and if we look at this now, we can see that the first byte is getting set based on our flags here. And yes, these are reversed. That's how it works, guys. That's how it works. This is byte 1. That's going to be byte 2, byte 3, and byte 4, right? For instance, if I want to set this, and you can use this for lookups. What did I mess up here? 1, 2. Okay, that's right. 2, 3. I can't type today, guys. Let me retype this. Alright, see what happens here, right? If we store this out, we can see that we're setting both byte 1 now, and I say it's B1 here, but this is B3, right? So that's what I want to talk, that's just what I want to show you guys real quick about unions within C#. There are some restrictions on this, guys. There's some restrictions on this. Let me go back to my chat here. Yes, I know, Zoof, I should use a uint, of course. It's just a sample, right? Yeah, what would be the use case in doing this, right? What would be, why would we want to do this? I think somebody had a good suggestion. We could turn this into, make that a uint, right? We could turn this into a color int. And now we could specify color as 255, RGB, right? 255, 128, 0, 255 full alpha. You probably want to get a default initializer on this so you don't have to initialize everything at once. Color int, right? So now by setting some color values explicitly, very easily, it will instantly map into a color uint if you want to store that as a uint somewhere. So C# doesn't actually define. So that's Indius, right? That's little Indian, big Indian, guys. That's where this can fall apart. This is where this can fall apart. Since we're explicitly putting some offsets in here, this will not, this code will not be this will not be usable on other architectures that swap this around, right? While this will work on Windows, this might not work on a Mac, might not work on some Unix systems, right? So you got to be very careful. You got to be very careful. While this will work in some of your cases, you just have to be careful where you're trying to target your software. If you want your software to run on other hardware where this is going to get switched around, right? When we say this is going to get switched around, you would have to put this at 3, right? You would have to say field offset for this to be 3. Well, even that won't work, but you know what I mean. You have to switch our bytes around. Unflexible code. But it's not. Yeah. Indianness is very painful in C#, guys. However, 90% of the time, this is probably not going to be an issue for you when you're writing .NET code. But just keep that in mind. If that is an issue, maybe you don't want to use this. If it's not an issue, this is a very handy little trick for you guys out there. Thimblebrit, yeah, you don't want to just take your struct and send it over the network. You always need to correct that data, right, on both ends of the pipe. So, another use, by the way, I don't know if anyone does this. If you're trying to use C# code and you're trying to communicate with native code, if you're trying to interrupt with native code, either pinvoke or execute within your process, you can execute native functions, by the way. There's ways to do that. If you're doing that type of stuff, sometimes the struct layout has to be explicit because you're trying to take a C# memory address, a C# struct, and you're trying to push it into the native boundary, and the layout has to be the same, right? So sometimes you got to do this for that as well. Register, C# has a communication layer to native code, yes. So that's what struct layouts are, guys. You can use this for unions. It's not just used for unions. Sometimes, like I just said, you have to have an explicit structure layout if you're communicating between .NET and native code, right? If you're trying to pass data, if you're p-invoking, sometimes you have to have a struct layout. And that's all that's doing. Okay, guys, let's move on to another topic. I just wanted to show that very, very quickly. I think it's kind of a cool little feature. Not used all over the place, though, right? It has some very specific uses. Like everything we're talking about today, guys, some of it has very specific uses, and that's okay.